Okay. Okay, next presentation continues what we started yesterday with Jeffrey, when we apply optimization constraint engine to solve decisioning problems. I can tell that this is not something new. 10 years ago, I published an article when we, instead of rule engine, we can use optimization engine to solve decisioning problem, and it actually unlocking full potentials, like Simon called it here, not and much beyond, and these potentials go beyond traditional rule engines, because instead of forcing people to define rules for all possible situations to come up with only one solutions, when you use optimization engine, you can define only limited number of rules that limit our constrained search space, and we can come up with multiple solutions. And if a user defines optimization objective, we actually can come up with optimal solution. And this movement is started, especially in academic area. And we do have product like Rule Solver, for example, .com, open source product that does this. But a few years ago, research team in KU Leuven started to be very serious about this, and they proposed something what they call CDMN, or constrained DMN. And today this team continues this development, and Simon is one of PhD researchers together with Joost, who do this work, and Bram. And last year they actually won the best paper on RuleML presenting this, but I think they have a serious progress. They made serious progress in 1 year, and today we will hear about this. Simon?
Thank you very much for the kind introduction. First of all, I would like to apologize if my audio is very echoey, because as you might notice, I'm in the garden shed. There was a lot of noise in the house, so I fled to the garden. So I apologize if you hear a lot of echo or a lot of birds tweetering. But yeah, thank you very much for the kind introduction. So my name is Simon Vandevelde. I will be presenting work that I did together with Joost Vennekens, titled Unlocking the Full Potential of DMN. Which admittedly is, of course, a bit clickbaity. As you might have noticed, a full potential of DMN, you can interpret that in many, many ways. What the title should maybe actually be is different ways to apply the knowledge in DMN models, but it doesn't really sound the same. It's also more lengthy. So that's why I stuck to the original title. Right. So the goal of the presentation is actually to show that DMN, as we currently have it, can be used in many more ways, like Jacob also mentioned, and we can do that by deviating from the standard approach, so to speak, with DMN. And one thing that you might notice me doing throughout the entire presentation, I will make a lot of air quotes just to cover myself in case I say anything dumb, so I can always cower behind the fact that I didn't mean it. So let's continue on. Right. So first of all, DMN now, I wanted to sketch a bit about the research that goes into DMN, right? Because as you've heard Jacob say, I'm a PhD researcher, so I'm more on the research side than on actually the industry side. And broadly speaking, we can divide a lifetime of a DMN model, I think, at least in two ways, or in two big parts, big chunks. We have the creation of the model, where a lot of research interest goes into, and then we have the execution of the model, where most people just assume that the execution of the model will always be the same, right? So the creation of the model, there we have some really cool, interesting topics such as knowledge acquisition. How do we best acquire our knowledge? Do we go to a domain expert? In what ways do we actually get the knowledge from them? Or do we start decision mining? Do we start other type of esoteric things? There's a lot you can do, but there's also topics like modeling methodologies, like is DMN actually user-friendly? There's some research going into that as well. Or when should I use the boxed expression, right? What is the trade-off? Then verification and validation, which is something that I've also dabbled in, where we can do testing of tables, or we can see, okay, but does the table actually have the correct outputs, such as the expert would expect, right? So a lot of research goes into those topics, but then on the other hand, we have the execution topics. So this includes interaction with DMN, such as things like chatbots. You might have seen this flying around earlier in different presentations, or how can we host DMN in microservices, or how can we increase the efficiency of execution. But something that I feel hasn't really been discussed that much is execution methods. Actually looking at DMN and seeing how do we actually execute it, right? Because currently the three execution methods that I have been able to find that are most current, so to speak, the first one is the standard bottom to top execution, where, yeah, everyone knows this. There we go. So it's 3 steps, right? We start at bottom inputs, we evaluate tables one by one, we go up in the table graph, and then we finish at our top decisions. This is by far the most intuitive way to execute a DMN model, because we have our nice DRD, right? We have our structure, and we have things called inputs. So we assume, okay, we need to use those as inputs, and we then follow it upwards. And we have nice arrows to guide us along the way even. So that's bottom to top. That's everyone knows that. I have an example here, which will also be my running example, which we call the BMI case. You've probably already seen this in a presentation by Veda earlier, where we calculate a patient's BMI based on their length and their weight. Then we decide on their BMI level, and then we use BMI level, sex, and waist to actually find out their risk level, right? So this is all fairly basic stuff. I don't think this is something that will surprise anyone. So yeah, so this is just an example of bottom to top. We start at our inputs, we finish, in this case, at risk level. Actually, yeah, I had a slide for that. Great. All right. So, for example, if we have a male of 90 kilograms who is 1.79 meters tall and has a waist of 100 centimeters, we would find out BMI 28, so overweight, and thus increased risk level. Again, all very, very basic stuff. Then we have reasoning on sub-decisions, as we started calling it. So imagine that you're only interested in a subsection of the model, right? We have this entire BMI model. Okay, it's not that big, it's only 3 tables, but imagine that you only want to reason on 1 table or reason on 2 tables. It would be very annoying to have to create a new DMN model that only contains that information. Yeah, because, right, so here, if I only want to find out what my BMI level is, I should be able to do that using just weight and length, right? But if I want to use the bottom to top approach, then I would also need to supply a value for sex and waist, which I don't care about. I don't care about risk level. So it's reasoning on a sub-decision, on a small part. So where my inputs for BMI level could be weight and length, but at the same time, maybe I already know my BMI because I only calculated it yesterday for whatever reason. So it might also be interesting to be able to input the BMI directly, right? And so instead of having to create a new model to do all of these things, we can just reuse the same model, reason on sub-decisions. And there's actually a lot of solvers that support this, because a lot of solvers allow you to reason on 1 table at a time, and then you do the rest yourself. So that's perfectly doable. And then we have something called wildcard mode, where, yeah, which actually allows us to reason on partial information, where we can set some inputs as wildcards, and then the system will output all possible outcomes. So for instance, if we, I think I have an example. Yeah, if we don't know the sex, but we do know all the rest, then we can just ask, okay, but what could all the possibilities be given that I don't know the sex? And then it would be either increased or high, depending on if it's actually a male or a female. So those are the 3 main execution methods that I was able to find. But I would like to talk a bit about alternative execution methods. And this is something that I feel can really amp up the game, so to speak, in the world of DMN, or not necessarily in the world of DMN, but in the world of using the knowledge in DMN maybe for different purposes. So we'll get to that. The main thing that I will be talking about is multidirectional reasoning. So imagine that we have just calculated that my BMI level is overweight, which is not that good, right? So the logical next question is, what should my weight be in order to be healthy, right? That's something if you find out that you're overweight and you want to start losing weight, it's nice to have a goal to work towards. So the easy solution would be just guess. Input random information in your model, let it calculate all the way to the top, and then you find out, here I would have a healthy BMI level, right? However, that's only possible for very small models, and it's never 100% precise. And also, just guessing, I mean, if you go to a professional, and then imagine you go to a doctor, and then a doctor says, I need to briefly guess what weight you should have, it's not a great idea, right? So, but what could we do? We could actually try to use the knowledge that is already contained in our DMN model, because we already have the knowledge to calculate or to decide our BMI level. Why couldn't we reuse the same knowledge in reverse, I should say, right? So why shouldn't that be possible? So here I have shown a very crude example, or not crude, but a rough example, where imagine that we could just change our DRD so that we have BMI level suddenly as an input on the right, and length as an input, and we use those to define BMI, or we use those to decide BMI, and then we actually are able to calculate our weight from the BMI value. I should also specify this is really not correct. This is far from correct, so don't actually do this, but it's just to give an example. Right, so yeah, actually, no need to change the DRD, because something that's interesting in the DRD is that it actually does not show execution flow. The arrows are not meant, or at least as we interpret it, are not meant to show you how the flow of execution should go, but rather the order of the definitions of the concepts, right? So we define BMI in concepts of length and weight. We define the BMI level in the concept of BMI, right? And so whenever I talk about we calculate BMI level based on BMI, yeah, that's only partially true. We actually define it. The value of BMI level is fixed based on the value of BMI. And so because these are not execution flow arrows, so to speak, but definitional arrows, we can reuse this knowledge without having to change the DRD around. So what are the benefits of this? Actually, it gives you endless new uses for a model, in theory. I'm not saying all uses are actually usable, because you don't want to find out a sex based on a weight and a length, for example. I don't know how that would be practical. But it does allow you to reuse a model to then calculate different stuff. And moreover, it allows you to reuse your existing knowledge. You don't need to start creating new models to, for example, find out the perfect weight, right? We can just use one model that does both. And it allows for easy answers to "but now what" questions. Of course, the question is, how do we do this practically? Which is always a big question. So theoretically, we could simply reverse a DMN table, which again, I should say is not correct. It does change the semantics. But in theory, imagine that we could just reverse the DMN table. And on the left, I have the original tables. On the right, I have the reverse tables, where I, for instance, moved BMI from an input to an output, and then BMI level from output to an input. And this immediately shows one caveat, right, with just doing so. And I think I have a slide on that. Yes, our outputs can now be arranged. For instance, BMI. So say that BMI level is underweight. This decision table would say BMI needs to be below 18.5, which is not a correct decision table from a DMN standpoint. But furthermore, it does not define a single value for BMI anymore. It just says your BMI needs to be below 18.5. So an output could be a range of values. It could be lists of elements. It might even be a wildcard. I'm unsure. I haven't encountered that yet, but who knows, right? And so in practice, we cannot just simply reverse a DMN table. Because, yeah, our outputs are actually now constraints. So if we say BMI level is underweight, then our BMI needs to be below 18.5. You can actually interpret that as a constraint, right? And it's no longer DMN compliant, as I've said. But what can we do? Because we have constraints. I was too fast. So in the case of a range of lists, this actually means that there are multiple solutions possible, right? In which each solution is equally correct. So if my BMI needs to be below 18.5, it could be 18, could be 16, could be 15. It's a bit low if it's 15, but it's technically correct, right? And some value of variables can become enumerations. What do I mean by that? Some values could become lists, or some variables could become lists where you don't actually expect them. So I have a small example here where we say that if I am 1.79 meters and I have a normal BMI level, or the outputs here would be that BMI is between 18.5 and 25, and weight is between 59 and 80 kilograms. So that's what we can derive from that. And so in this way, we have a solution space, right? Every value of BMI is a correct value, and we don't have a single solution anymore. So we can do more than actually reasoning in reverse. I've now shown how we can reason in reverse from a table, but we can just reason from any variable to any other variable. And as I've said, it's not always useful. For instance, there's not much sense in deriving sex from weight and length, I'd imagine. But we can do it, so why not, right? So some other examples, because I've been talking about the BMI case a lot, I have some other examples listed. So imagine that you have a DMN model, right, which calculates a pension or a retirement wage, I should say, based on age and work years and etc. One of the logical questions is, of course, when can I retire if I want an income of X per month to stay financially viable, right? And something like that we can perfectly do by just taking the original DMN model and here using it in reverse, using the same knowledge. Or a ticket price calculator. If you want to travel to a certain place, at what time will it be the cheapest? It can tell you if you go in September and you don't go in a school holiday, tickets will most likely be the cheapest. Stuff like that is instantly possible to calculate just by using multidirectional reasoning. We don't need, again, a separate model. Or two more examples. If we have a system which can check eligibility for bonuses, what can I do to gain more bonuses, right? If I want to get rich quicker or quick, then what things can I tweak? Can I, for instance, donate to charity and then get a tax rebate? Or can I do some volunteer work and then my company gives me a bonus? Stuff like that we can still change, and then that might be interesting. Or in the case of loans and interest, what should I have to do to have an interest rate of 1%? Imagine you're buying a house. Some parameters are usually fixed, right? The price of the house and the amount that you will have to pay for the actual terrain that the house is on. But there might be some things that you can still change a little bit, or like things like having a different notary might help. But I'm certain that there's also some other stuff that you can still tweak to have a low interest rate as possible. Now, of course, as with any good technology, sadly, this could also be used in reverse. Say that you have a notary who wants to have or you're a bank and you want to always have the highest interest rate possible because then you get the most money. Technically, you could also use it for that purpose. But I don't condone that, but it's possible. Another thing that is, of course, interesting is optimization of a DMN model, right? So in the BMI example, we asked, what should my weight be in order for me to be healthy? But actually, what we're asking is, what is the highest weight I can have in order to be healthy? And for that, we should use optimization, right? And so then we can say, again, I'm still as tall as ever. I have a normal BMI level, or I want a normal BMI level rather. What is the maximum maximum weight that I can have, which would be 80 kilograms? What is the minimum? 59 kilograms. So I should stay between those bounds. But that's something where optimization can really easily help us out to find such information, again, without having to create a new model. Something else that is also relevant is that variables might sometimes not be relevant. I'm not proud of that joke, but so consider that your BMI level is normal, which in the first rule, which is applicable in the first rule, then the value for sex and waist would be completely irrelevant, right? So if you are actually performing bottom to top approach, you wouldn't need to input that information. Now, in this case, that's trivial, but consider the example of having a chatbot, right? That's two less variables that a chatbot would need to query a person for. It wouldn't need to ask their sex, wouldn't need to ask their waist. It can just ask what is your weight and your length, calculate BMI level, and if it's normal, then it can immediately tell you that it's low, right? So that's relevance in that sense can help us reduce the number of queries that we would need to make towards the user. Now, so or if BMI is below 25, then we don't need to know sex or waist. And this is not something that we need to know in advance. We can use the knowledge in our model to derive this relevancy, right? We don't need to already, because of course I could just write down in my chatbot, I could program it, if the BMI is below 25, don't bother asking sex or waist, but we're researchers, we want to go the full mile. So we should be able to detect those relevancy things on the fly, right? Right, so I've been talking 20 minutes about a lot of theory. Let's now delve a bit deeper into practice, which is of course a lot more fun. Because how do we actually implement those novel execution methods? Any programmer here knows that, it's trivial to use a DMN model in one way, but how do you actually use it in a different way? We can't use the current execution engines to reason backwards, or at least not with a lot of adaptations, right? Reversing a DMN model isn't DMN compliant, so you couldn't just create a program that reverses them and then use those. So the question is, how do we best deal with constraints? And the solution, as it has been shown on the slide for a long time now, is of course use a constraint solver, which is always a lot of fun. So I have we rather have two concrete applications already that are based on this approach. One is called DMN-IDP, which combines DMN with a knowledge-based AI reasoning engine, but I think I have more information on that on the next slide. And then the other is DMN-IDPY, which is similar to the earlier, but then in the form of a Python API. And it's the bottom one that we presented at RULML this year, together with Vedavias Etikala and, of course, Jan van Tiene. And so both of these use KU Leuven's IDP solver or IDP system as an internal constraint solver, just to show that it's practically feasible as well, right? So what is DMN-IDP? Yeah, it's a lot of three-letter acronyms, I realize, but just bear with me. So DMN-IDP combines DMN with an IDP-based interface. And what's the idea behind this interface? The idea is that, well, DMN is very user-friendly, very readable. We want to use IDP to reason on this knowledge, because this allows us to do all this fancy stuff that I've been talking about, right? And so then we head out to start building an interface that actually is also user-friendly, with the main aim, of course, of not losing the initial user-friendliness of DMN. So what do we do there? We translate DMN models into an IDP knowledge base, and this is then viewable in an interface that we find user-friendly, right? So it's very easy to click on buttons and enter values. And so the interface supports bottom-to-top reasoning, but also the multidirectional reasoning that I've been talking so much already about, but also optimization, reasoning on incomplete information. So say that you don't know the sex, you can just have it do generate all possible solutions. Or alternatively, it also has support for the relevancy, where you can say, or where if you already enter your weight and your length, you won't need to actually also enter the sex and the waist, because it can immediately derive your BMI level and then your risk level. So that's interesting. And also something that I forgot to mention on the slide, it also has support for explanations. So if you, for instance, if you doubt your BMI level, if it's a bit too high and you think maybe the system made a mistake because I should be healthy, you can ask the system, but why does this variable have this value? And it will be able to tell you, we use this formula to calculate the BMI, right? So that's pretty simple. But we could also ask it, for example, why is my risk level high? And then it will tell you, because we have calculated your BMI as being such, which leads to a BMI level of this. And yeah, so, right. So the explainability is also in the interface. Right. And now I have prepared a demo. However, due to technical issues, I will have to very awkwardly start sharing a different tab. So I'm very sorry.
Simon, we're seeing your screens, but we're not hearing anything.
Yes. Okay. I think I fixed it.
Okay.
Oh, thank you so much for telling me. Or it's been really awkward. Right. Okay. So I'll continue. So all right. This is DMN-IDP. It's a bit small. I apologize. So on the one hand, in our web browser, we have a nice DMN editor, right? Which is just box standard DMN editor, which allows us to edit our tables ourselves. But then we get to the DMN interface, right? So now the DMN model has been translated into IDP code already, and it's hidden here under view IDP. I don't know if I actually show it in the demonstration. And it's this IDP code that the interface actually runs on. So it generates a tile for every symbol that is known in the system. So this is length, waist, weight, BMI, BMI level, sex, and risk level. And then we can enter values. And note that it does not distinguish between what level a symbol is, right? All the symbols are a bit everywhere. There's no distinct order because in IDP, we don't have a distinct order, right? And in multidirectional reasoning, we don't have a distinct order. So I can enter my length, I can enter my weight. It will be a bit calculating, and then it will tell me that my BMI is 28, and that my BMI level is overweight because it can immediately derive this. So then I can say, okay, I'm a male and my waist is, I assume 100 centimeters. Yes. Then it will automatically calculate, risk level is increased. So that's the only option. So that's the standard bottom to top approach, right? But of course, we can do much, much more, as I've been telling the entire time. So if we say that, okay, I want a BMI level of normal, and I already have a weight of 1.79, I can't change that. Then what should my weight be? And it can immediately tell us. It can't immediately tell us. I'm sorry. Yeah, no, of course it can't. Now I can minimize or maximize to find out what should my weight be. I'm very sorry. I should have a weight of 80 kilograms, as I've shown earlier on the slides, which would lead to a BMI of 24.999, which of course is just 25. And all the other variables, you might have noticed that it told me that my sex was female, and it probably found something for risk level as well. It just filled in randomly because we aren't actually interested in that. So IDP just gives us something random there. But of course, we can go further. We can say, okay, I want a risk level of low, and it can immediately tell us that sex and waist will be irrelevant, as you can see. It grays out the fields, by which we already know, okay, we don't need to enter any information here, because any information that we do enter here will just be irrelevant. It will be lost in the ether of the universe. So if you then enter our length and our weight, it will tell us that, yeah, we have a BMI of 25, right? So, okay, my cursor keeps moving. Yes, if we then enter that we have a length of 1.79 and a weight of 80, again, it can immediately tell us that our risk level will be low because our sex and waist is irrelevant. And so we don't need to input that anymore. We don't need to query a user for that information anymore, in the case that we did have a querying system set up. But then if I change my weight to 90, my BMI level will be overweight again. And interesting to note here is that it immediately excludes what variables will never be possible anymore, right? So a risk level of very high is impossible to have with an overweight BMI level. The only two options still left are a risk level of high and a risk level of increased, right? So the more information we add to the system, the more precise all the other variables will get, which of course makes a lot of sense because all we're doing is entering information. Based on this information, it can do calculations or it can find some constraints, and we can constrain the solution space more and more, right? So yeah, okay, here I'll be asking for an explanation. This is one feature. Yeah, there we go. So here it can tell us, okay, your risk level is high because you are a female. Your length is, yeah, I entered that myself, by the way. Length is 1.79, your waist is 100, BMI is calculated as such, and weight is 90. And then it can tell us the laws that have actually been used. We have still some cleaning up to do there to present it in a more user-friendly way. But it does already show that you can use this same DMN model in multiple ways just by inputting it in the system, right? You don't need to do anything fancy with it, no editing the model, just plug it in and it should work. So that's that demo. I will now share back, and yes, I will uncheck share tab audio so I don't make the same mistake 3 times. Right, so I should still be hearable. Yes. Great. All right. So that's DMN-IDP, our first application based on everything that I've shown, right? And then we have DMN-IDPY, which is just a letter difference, and which we presented at RULML, as I've said, which we created together with Veda Etikala and Jan van Tienen, which is similar to DMN-IDP, but then in API form, because in the other interface, you're stuck with, yeah, it actually being an interface, right? So if you do want to implement such a thing as a chatbot, it wouldn't be possible, or it wouldn't easily be possible using such an interface. So we converted it into an API and we added a lot of more features. So it allows you to load a DMN XML file just in Python, and then it allows you to start using it in any way that you want. So you can use the bottom to top approach. I will demonstrate this, or I won't, but you can use the bottom to top approach where you just enter the variables. You can reason on incomplete information. So if you don't know the sex, for instance, you can also do things such as relevance. Multidirectional reasoning is, of course, also supported. Querying if a variable is known is something that is pretty interesting, because in our API, how it works is you can toggle on propagation, and what propagation will do is, every time you enter a value, it will immediately try to find out how that influences the rest of the system. And so this means that if you enter weight and then enter length, yeah, IDP will immediately be able to calculate what your BMI is. And so you should be able to query if a variable is already known. So that's why I've also listed that there. And then you can also do some standard querying of the variable type and what the possible values are. So this is just listing the information that is in the DMN model itself. But you can also do optimization, as I've shown earlier. So I also have a quick demo for that. So this is a 25 lines of Python code, yes, that I implemented myself. And I will be showing the demonstration for it later. But basically, all it does is it loads in a DMN model. It can just be any DMN model. It will tell us what all the variables are in the DMN model that aren't inputs, and ask us which ones we want to calculate. So this is actually an example of subdecision. So it will ask us, which variable do you want to calculate? And it will only query us for those variables that are actually relevant to query in that case. Because we can just always check, okay, do we already know a variable, right? For instance, if the BMI is, what is it again, 23, we will already know risk level because our BMI level will be healthy. Yeah, and I think the demonstration will show it better than me saying words. So I will have to share very awkwardly again, but this is last time, no, the second to last time. And this is an even smaller screen. For which I really apologize, but technical difficulties got the better hands. So this is just some terminal output, which of course we can put in a nice interface. So like I said, it asks you what variables do you want to calculate, and so it lists risk level, BMI level, and BMI, because those are the 3 intermediary or top level variables. And then it will tell us, okay, if you want to calculate risk level, we need to know weight, length, sex, and waist. And so if we enter a value as waist, for weight, we can say 100 kilograms, 1.79 meters. If I'm then also male and I have a waist of 100, it will tell us, risk level is high, right? So that's just basic usage. That's, again, bottom to top approach, but with a bit more interaction. So you could see this as a very, very dumb chatbot, so to speak. But we can go further, of course. We can say, okay, I only want to calculate BMI, and then the system will be able to tell us, okay, you only need weight and length this time. And then we can just set those values and it will be able to calculate our BMI. And so this is a very trivial example. I realize you could do this probably in any other reasoning engine as well. But still, I find that it shows a bit of the flexibility of having such an API. Because we can still do much more than the things that I've shown now, of course. And now I need to switch one last time. Yes. Whew. So the main thing why we're actually doing this in our research group, right, is we are trying to find out in what or how much or how feasible DMN is to be used as a knowledge base for symbolic AI, right? Because it has a lot of advantages. DMN is user-friendly, DMN is readable, and it is sufficiently expressive to model a lot of different cases. For example, the BMI case, right? But what we found was that the current execution methods are limited to actually have really flexible symbolic AI. So that's the main motivation behind our research about combining DMN with IDP, as we've done in 3 ways now, the 2 that I've demonstrated earlier, but then also, like Jacob said, we also created CDMN, which we showed last year. And so that's our main motivation. We want to find out in how well we can actually use DMN. Because it's, of course, a huge advantage to have a user-friendly representation or a readable representation for example, the brains of your chatbot. If you can just plug in any DMN model and a chatbot can then interact with it, it's super easy to actually see what it's reasoning on, right? And so here's another example. Imagine that we have a cobot. So we have a nice, cool robot arm in an assembly line where we are creating product X. There's an operator right next to it, because of course it's a cobot, and it already knows preset procedures. And this is something that we could probably model in DMN. It should be feasible, right? So stuff like screw in Y or verify the weld line quality or give operator screwdriver if C happens, right? So these are all things that we can probably model without too much hassle. However, does the standard functionality of DMN, right, the bottom to top, does it suffice here? Is what we are then wondering. And so this is why we created the API, for instance, because if we want to perform task by task, we would have to reason on sub-decisions, right? Because a robot might sometimes, so we could have an input variable that might not be known at the very start, and it might be interesting to just work our way towards it and then find out whether we need it or not, right? Or we can also do some other stuff like find all situations X in which the robot will turn past the operator so that we can tell the operator to duck if necessary, right? So this is a form of multi-directional reasoning. We can set in advance a robot needs to turn to the right, and then we can generate all the possible models, all the possible worlds in which this would happen. Or something like only turn on your necessary sensors, because imagine that it's running on a very small embedded board and running a sensor costs a lot of power wattage. If we only turn on the necessary sensors, we need relevancy in order to be able to do that, to find all the sensors relevant. Or stuff like how do we prepare for procedure Y? If we already know that we are going to make a weld line, how do you actually prepare for that? What tools should our robot have? Or optimization, what is the optimal number of screws? Here's where I start reaching at straws, but it's okay, we're doing research. So these are a lot of things that we can do or that we can express in a DMN model, right? So that just the behavior of the robot, but then to actually use it to control a robot or to control the things around the robot. Like I said, if we want to know when does it turn to the right, we need the alternative execution methods that I've discussed, right? So that's a conclusion. We can do more with the DMN model without ever having to change the DMN model, just by adding support for more flexible execution. And so don't get me wrong, I'm not advocating that every DMN engine should be able to do all these things, right? I'm advocating that there are cases in which it is very useful to be able to do this. For example, in a cobot, or if we create a chatbot that queries or that you can interact with for a BMI case, right? And so we need to support, in those cases, more flexible execution methods, such as the reasoning on incomplete information, multidirectional reasoning, optimization, and maybe wildcard mode. And so this allows a single DMN model to have multiple purposes, and it has a huge potential in combination with AI, as I've said many times already. So I would like to thank you for your attention. I'm sorry that I've probably been all over the place, but yeah, I would like to thank you either way. If you have any questions, feel free to ask them now or put them in the Slack, or if you have any questions afterwards, feel free to email me and I will gladly respond.
Thank you so much, Simon. That was great. I was interested that you. First of all, I think you have a very nice garden shed. So,
thank you.
You mentioned that you had authored a paper together with your colleague who presented on Monday. So it was, and they were talking about the chatbots and so on. Are you seeing a lot of synergy between the research that you're doing and that they're doing?
Yeah. So. This paper or the DMN-IDPY API was created with Veda, who is working on the chatbot, and the main idea for the API, where we realized that it could be useful, because Veda came to me and told me, hey, I want to build a chatbot based on DMN, but we need or we would like to use IDP, can you help me with that? And so that's where we started. And then I started working on API. We realized we can actually do a lot of stuff with this, and we just kept on adding. So in the future, that's definitely on the table. So hopefully maybe next year, Veda, if you're here to set a deadline, DecisionCAMP 2022.
I don't see him on here, but he's not on Zoom. So it's Veda's presentation on Monday was really very interesting. Jan is here, although Veda is not here. So Jan just popped up in Slack and said that he's here. But I do want to address a question. So Denis Gagné had a question to ask if by DMN, do you only mean decision tables, or are you also including all boxed expressions?
It's a very good question. Boxed expressions is something that theoretically we can express, but we would have to jump through a lot of hoops. However, so the motivation behind the reason why we're doing this, which is the same motivation, of course, was in the first instance that we needed something that was very user-friendly. And I'm going to say something very controversial here, but we often find that as soon as we need to add boxed expressions, we've gone past the user-friendliness. Because if you start writing things that really resemble procedural codes, I'm not advocating against it, but we just find that we can probably express that better in a different way, maybe.
Okay.
Denis, but yes, boxed expressions is.
Does that answer your question, Denis? Or if you want, you can
yeah, no, I was
unmute yourself.
Completely. I was curious whether there was some interest in digging more into the execution semantics of DMN, because I think this is a very nice track of research. Jacob has done some work along the same line, and I do agree. And it is something that we see. The requirement for doing backward kind of chaining reasoning to only ask the proper questions and the question needed, mostly when you're in a questionnaire setup, which a lot of financial and healthcare contexts are driven by questionnaires. So there's a lot of need for that. But we want to make sure that our execution semantic is still sound and complete. And so that's why I was interested in seeing how far you can take this or want to take this, because it could be interesting. Because although there is some statement available within box expression that may resemble programming statement, it is still an expression language that is mostly functional in nature. And Matteo is there. Maybe I'll jump in to talk about how you can actually do a more complete type of reasoning on this, but yeah, and this is a very interesting track, and I hope that there's going to be more and more research on that, because, and I'm really meant to motivate you to look at deeper box expression and how that can be involved into this, because I think that's going to have a lot of value.
Thank you very much.
Yeah, Matteo did jump in with a comment on Slack to say he loved the presentation because it's quite meta on DMN. So, so hopefully that's what you were aiming for.
Yes. Thank you very much.
Okay, so we do have a question from Bob Moore. He says he might sound like a broken record, but this does seem to be another case where using something closer to a relational database table rather than decision tables would give you extra leverage. Do you have any thoughts on that?
Yes, yeah. Of course, he's absolutely right. But I feel that, again, as I said multiple times before, our main motivation is to have this user-friendly representation. And again, I'm not trying to be controversial on relational databases, but oftentimes those also lose their, or they're not so user-friendly towards a domain expert anymore. But indeed, it is something that it would be, it's starting to sound like a relational database table.
Yeah. Well, and Jan jumped in and said, well, a decision table is not so different from a relational table. So it's just, yeah. Now, Matteo had a question about, can we assume that this works for only a subset of field?
Yep. So currently we are limiting ourselves to S field, right? Which I've been told last year was actually didn't exist anymore, but I didn't really find anything on it. So we're limiting ourselves to a subset of field. There's a lot of expressions that we will probably be never able to model. However, something like starts with, you can model in some constraint solvers that do. There's a type of constraint solving that is capable of doing such things that reason on meta representations. But it is indeed, voilà, S field still exists, but it is discouraged. Yeah, we limit
yes,
to
yeah.
S
Oh, you're
field.
reading you're seeing the Slack channel. Okay, all right.
Yeah,
and Denis, I think Denis, you wanted to hop in with a comment, or?
Oh no, I was just gonna note that it is within the spec that S field is.
Okay.
I was going to be a little bit more stringent than Alan. I was going to say it's deprecated. We realized that the execution semantic of S field was not sound and complete. So.
I just want to support what Simon just said, and actually all field expressions that don't have loops or function calls could be transformed to constrained expressions and use as constraint. And I'm sure they support this, or they will support this. But I also want to just tell that it's one of the presentation that extends potential functionality of decision modeling and goes to these human applications, several of them Simon mentioned, and I want to tell you, for example, one real story. When I cooperated with a University College Cork in Ireland, one of application was the similar system controls a laser when doctors in hospital remove cancer from brain of, and they trying, when they do it manually, they also make mistakes and remove healthy cells. And the system what we had optimization objective to minimize this routing path and to minimize damaged healthy cells. And this system really worked and was one of the most impressive use of these technologies that I ever seen. And thank you, Simon. It's really good direction, and I hope you will continue, and you and your colleagues will continue to do it.
Thank you very much.
Okay, we're going to have about a 10-minute break while we get set up for the next presentation. Thank you.